So we know object-oriented languages since decades, right? So probably I don't know where you start. If you start from Delphi or you start probably from the C++ or maybe Java. So the object-oriented was everywhere, and it was the main paradigm. And for sure, that we all know about Smalltalk, about the contribution of United States to the programming. That Smalltalk it's a pure object-oriented language, and practically everything in a OOP world was invented in Smalltalk community. But the real truth it's that Smalltalk was inspired by simula. And the root of object-oriented programming actually it's not coming from Smalltalk itself. And all the roots of the object-oriented programming actually start in Europe. And as a majority actually of the concepts that we know today. Yeah, it's not popular, but a lot of computer science invention actually is the European thing. And what's extremely interesting in Simula that Simula had more pragmatic function calls similar to modern class procedure and function calls. It was statically timed, and it's remind more the C++ than actually Smalltalk. And it was actually the the most interesting thing that Simula was designed as a simulation language. So the objects was the side effect. It was never the main goal. The main goal actually was the real simulations, and to do the real simulations, actually the biggest part was the coroutines, semi-parallel execution, and the objects that could be the separate execution environment. So the main idea of the simula was to build the real or close to real environment that simulate the queues, the delivery networks, traffic networks, and so on. So it was mainly the root of the object-oriented programming was never about the objects. It was the communication of the complex system and simulation of the events. And actually, it's built the huge amount of real world things, but maybe it was not so pure and philosophical and sexy as the Smalltalk offer, but the Simula was pragmatic extension of Algol that faced on the simulation problem. And their coroutines and even their approach that procedures could be independently implemented from the classes, and procedure could take the function or procedure as a parameter, make the similar probably uh, complete functional language. Actually, if you really want, you could write the functional similar. And actually, I guess that Smalltalk also borrowed the idea of the blocks from the idea of the similar procedures. So it's yet another substantial uh, um, thing. But all the modern systems with the microservices and even the agentic AI and independent agents, they all somehow based on the ideas that Simula brings with the as a simulation language. And it's quite interesting to see all these historic parallels and all the features of the Simula that was missed when we designed the Smalltalk. Because we don't have even in the modern days the languages that allow us actually to run the real simulation of the complex agentic systems. And for sure, this complex simulation of agentic systems could be extremely useful, even for building and studying the interaction of the LLM agents and do a lot of agentic work. For sure, we have the actor frameworks and the isolation and all the things. And simula was pretty much naive because for the communication between the coroutines, you use the shared state, you use the properties directly in objects, and it was very naive. But you need to admit it was 1962, so it was way before I was even born. But the idea of the coroutines and real-time simulations and actually encoding the time directly and having the ability to control the time as quantitative and predictable ticks of the events make the simula quite interesting language. Not maybe to study, but at least to take a look and learn something even for the agentic world.